let's start with the topic, automated refactorings with Open Rewrite. My name is Merlin. I'm a software engineer slash software architect with Adesso, and I'm an active contributor to the Open Rewrite community, as Tim notes, so I'm okay to say that. Today I want to dive into Open Rewrite a little bit different, not the very technical view, just from a higher view, but don't run away, we see code, so it's safe. Why modernization or refactorings in the first place? If we look at this image, we have an old double-decker and an Airbus. It's not a Boeing at this picture, and why we migrated, or the airplane industry migrated from a double-decker to an Airbus. The double-decker has everything. It flies. Done. But the requirements changed. A lot of people want to fly, they want to fly faster, they want to fly safer, they don't want to fly in a wooden airplane because they don't trust wood. Whatever, it changes, and we migrated to an Airbus, and now everybody is flying Airbus and less of DC-9 or so. But it doesn't happen in a big step. It happened in small incremental steps, and these small incremental steps are similar to the small incremental steps we see in our software industry, but with a different pace. From the double-decker to the Airbus is about 70 years, 80 years, depending on the version. For Java, for example, it's nearly 30 with a lot of innovation. Let's see that over time. We have the JDK enhancement proposals here grouped in arbitrary, not really arbitrary, but grouped into times. And the JDK enhancement proposals are the proposals to further develop the JDK ecosystem, so the basic ecosystem, so at least my basic ecosystem. And we see from 11 to 4 to 21, 10 years, there's a lot of enhancement proposals. These enhancement proposals propose API changes, which in fact affects our software directly, deprecations, which may affect our software, performance increases, maintenances. So it makes sense to stick with a newer version just to take advantage of the new things. Big problem is, or not a big problem, but problem is, the longer you stay at an old version, the harder it gets. And with every release, it's getting harder to migrate to a newer release. And it's getting faster, way faster. If you look down at the Java line from Java 7 to Java 9, that's let's say Java 8, that's 3 years. Let's see, 3 years is from Java 11 to Java 15. And it will stay at that pace, and that pace is great because we're getting new features, we're getting new fixes every half a year, but it imposes a new problem that we have to migrate at least every 1.5 years between two major versions, two LTS versions. The ecosystem, like Spring above, that's Spring Framework, so don't get confused with the 5.3, that's not Spring Boot. It has also a very short release cadence, and it's also getting shorter. And it imposes a new problem to us, because the newer frameworks like Jakarta EE10 and Spring Boot or Spring Framework 6 require us to use Java 17, which is not yet on that slide. And so now we're on the point that we're not only have the urgent to migrate for security reasons or for performance reasons, but simply to keep our application running. And that will again and again come the next years. So Now is the time to migrate our old double-decker up to an Airbus. And everybody has this applications, and I suppose, and I think it's not only one, it's 3, 2, 5, 20, 100, you name it. It's not only one. So we need modernization. And how modernization work usually? Let's have a quick look. Modernizations are composed of small refactorings. In the terms of software engineering, it's small refactorings. And small refactorings, as Fowler defines them, refactoring is a controlled technique for improving the design of an existing code base, blah 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 blah, each of which too small to be worth doing. And that's a big problem. Because if we get the time to adopt every small step, a big migration is not a big deal. But usually we don't get the resources, because the resource is pure money. And the result is behavior preserving. The result is basically nothing for the product. So where does the money come from? No one knows. Let's see what small refactorings are. Small refactorings are something like this. Just use another method. Sounds simple, right? And it is simple. We have an awesome service that uses another service. Let's say that's some internal Spring Bean or so, or some Jakarta Bean. Or in the terms of if you stay with Java SE, it may be random, the class random. Random is not really deprecated, but it's you shouldn't use it. Let's say we have to migrate from one service to another. Just search and replace the method. You're done. Great. But in a lot of cases, it's not that easy, because it's not just search and replace. It's maybe search and replace and flip this to arguments. Okay. Another migration which is often simple is just use another version. A newer version of JUnit, for example. JUnit 4 to JUnit Jupyter. It's JUnit, it's not that hard. Even JUnit Jupyter uses JUnit under the curtains. But we have to change before each, after all. That's easy. That's again search and replace. But are we sure that we are picking up every before and before each? Everywhere? And now there are a few interesting parts, like expected exceptions, or timeouts, or enable, disable. And every step of that is very easy, basically. It's basically search, and most of them is search and replace. Some of them is search, think, retype. Easy. Okay. Just some numbers, imaginary numbers, because everything is individual and depends on your software. But numbers, you can count it in your head yourself. The setup annotations for the JUnit example, I would say for before each, before all, it's about 30 minutes per annotation. Search and replace in your project, it's okay. The timeouts, you see in this, there's a new timeout annotation. Okay, it's again search, but it's not search and replace, it's search, copy, replace. Okay, 10 minutes per usage. Okay, not that much any. Expected exceptions, same thing. Search, copy and think. Maybe 10 minutes is a little bit too low, because you have to type some assertions, but let's say 50 minutes. and now times your hourly rate. Now it's getting expensive. It gets really, really expensive if you count that in, and we have changed nothing. We preserved the behavior. And we have to repeat it on a big project landscape. Okay, basically that's not a project landscape, that's the traffic flow of Netflix as it was, I don't know when, I just found an image which looks like a cluster. But it gives you an idea of your internal project if you think about it. I suppose you don't have one bubble and then not connected bubble next to it. There are connections between them, and there are a lot of connections between them. There are a lot of software to update, and if you do this small example with the annotation change and the timeout change once for one bubble and multiply it by all these bubbles, you see it's really expensive. And that's a reason why a lot of decision makers or product owners are not happy with upgrading. What is a bad thing for us developers? It is a bad thing for the product, but it's not that visible as some, let's say, customer complaints. So we've done a lot of manual work now, but like CI/CD, it is a great idea to automate that stuff because it's always the same. It follows a pattern. It's great for automation, and automation saves money. And Open Rewrite by Modern is one tool that gives us the ability to automate refactorings, and therefore, if we combine small refactorings, automate migrations. Open Rewrite is an open source project. Modern is a company behind it. Initially open source, Open Rewrite, and providing additional services, additional software on top of that, to protect us from a vendor login, and protect us from a license change like HashiCorp or Terraform or so. Open Rewrite joined in the beginning last month, I think. The new founded Common House Foundation, and Open Rewrite is now not disconnected from Modern, but Modern does not have the rights to change the license anymore. So it's an open source project, a real open source project, and it will stay an open source project. How does Open Rewrite work? I said Open Rewrite applies repeatable steps which follow a pattern. It's similar to this assembly instruction from IKEA. You see, you have a handful of screws, you have a handful of wood, you have a screwdriver. Oh, we can assemble it to a coffee table. It's similar for Open Rewrite. For Open Rewrite, it's not instructions, it's recipes, like cooking. But it follows the same pattern. I see something, it fits my precondition, I transform it, and then we have the new code. How this support is, I will fix that in the in the slides. We see it right here in the recipe catalog. It's a lot, and it's not only Java. It's building tools. There are building tools. There are deployments. There are CI/CD. There's even Node.js, and maybe there are coming some other languages, but we have a look at this catalog in a few minutes. Here once again, the very important state of Jonathan Snyder, one of the co-founders of Modern, that Modern is committed to open source, and Open Rewrite will stay open source forever. Just if anybody just asks you, but that's a commercial tool behind an open source code. No, Open Rewrite is open source. Everything that named modern is not open source, but it is open usable to a point. Okay. One minute. I have forgotten to comment in back in my slides one thing. Exactly the chapter we want to look at right now. Sorry, I had a layout problem this morning, so. Now it should be okay. Yes, now we're okay. Let's start migrating stuff. It's pretty easy to start with, and I will hopefully take you in a live demo. Let's see if the internet connection works. If you're here, when I was alone in the room, it worked quite well. Let's see. I will start with the more easy thing, the thing you can just simply spin up to every decision maker, every management people, just showing them, look, we can change our code very easily, refactor our code very easily, upgrade it. Later on, we will see the more technical way of migrating things. It's big enoughness, yes, just the address bar is not big enough, but if you search for modern IO, then you'll land on that page very quickly. We can sign in with GitHub or Bitbucket, and yes, it's working, great. That's the platform, that is the paid part of Open Rewrite Modern product cluster, but it's free for every open source project. So you can head over to Tim and say, hey, my open source project needs migration, I want it into the modern platform and play around with it. You can have it. I've selected some. Let's say JavaPro. Does anybody know JavaPro? It's a very very old Java tool to manage your references for LaTeX. And it stopped developing, and development stopped, I think, 10 years ago because it worked. Now it stopped working because of an JDK upgrade. And now there's migration effort going on. But migration of otherwise we want to migrate something. Let's say we want to migrate that we want to remove an annotation because we have very lazy developers which are pressing a lot of warnings like unused or so. We use the example here, that's not that bad, at java.lang.cypress warnings, sorry. But it's a good example. If we run it, we started something called dry run. It's scheduled in the background. It's done in the cloud, and now it's finished. We can look at it, and we see there's nothing changed. Why? Because I mistyped. But I'm already there. You can build bigger receipts with this platform just by combining existing recipes, like the removing, or we could add another one. Here now I have Cypress warnings. That's the correct part. And on the right side we see the first technical thing. That's the thing which is behind that. That's just a fancy view for this YAML recipe. That's a declarative recipe. It has a name, which with it is identified. It has a display name, which is part of the automated documentation. Has a description, which is also part of the automated documentation. And then we have the configuration for this remove annotations recipe, which is an not runnable recipe on its own. It needs configuration because otherwise it doesn't know what to do. So let's quickly run it again. We see it's queuing, it's running, it's very fast. Keep that in mind. Who is playing now? Okay. So now we can see the patches. And that's a very important part. Open Rewrite in the modern platform. So Open Rewrite basically is just a tool, and it's not doing your work. You still have to commit. You still have to go through the review. Should go through the review process, and just don't commit things blindly, because if you say the tool just remove all our Cypress warnings, it may remove something like constant conditions, which is a compiler warning, but maybe you've checked it priorly, so it's okay to keep. From here we can directly commit or open a pull request. That's quite easy from this part here. Let's take a step further. Let's assume we want to do our own recipes. Now we're at a receipt catalog. As I said, there are a lot of pre-built recipes. One of these pre-built recipes, for example, is the best practice. For example, best practice for RVS 9 Open Rewrite best practices. That's a recipe which just applies the best practices when developing recipes. It's an interesting recipe to continuously run if you're developing your own recipes. What I want to show you is the recipe catalog, or the details page on that recipe. That's the auto-generated part of the recipe, and it has this very neat usage part. We just can copy it and we're done. We can now switch back to our IDE and just, I think I haven't reverted yet, so it might not do anything. It looks the same. We just scroll through it. It's big enough or bigger? Top. I use the Maven integration just because I'm a Maven guy, and I like Maven more. I'm running the Open Rewrite recipe, the Open Rewrite plugin with a recipe. The important part is Open Rewrite run here. It states that it runs the Java receipt best practices. It applies no styles. It's resolving the POM, while without knowing the dependencies, it may not be possible to migrate everything. And it's passing source files, and then it does changes like migrate test annotation. Let's see what changed. Nothing. Okay. Then we run it again. Sorry. No. Thanks, Outlook. I don't want to be part of this. It's running on Java at the moment. Because it's a Java tool, it's running on Java. Don't be afraid. It is able to migrate non-Java source code, so it's just running on Java. Now it's resolving the problems again, and you might see that it takes a little bit longer than the modern platform. That's a technical reason we see later. And yes, now we have a change. We could commit that. It renames a variable. Renames a variable and adds some braces. Done. That's a maintenance migration. We could migrate differently. Like, let's say a very interesting one is Spring Boot migration. It's easy as that. Oh no, not this one. Spring Boot migration. Yeah. Sorry, that's not the recipe. Anyway, we can migrate Spring Boot the same way. We could just look at the catalog, say we want to have Spring, we want to upgrade Spring Boot 3, and we take this migration. So if we have a Spring Boot migration, Spring Boot application, we could use this recipe to upgrade to 3.2. It also integrates the upgrade to 3.1, 3.0, back to 2.0. I don't know if it is working quite well, but it could technically, and it's resolving them. What is interesting for you to know, if you don't find your own recipe or your recipe of need, and you don't find a pre-existing recipe to configure it like you need it, just take the recipe starter. There's a starter, you can write your own recipe, and for every recipe type there's a different there's an example there, like the migration YAML we see before. Before it was a removing of annotations. Now it's a change of type. I change the before class to before all. If that's not enough, we have different types of recipes, but just let us jump back here. We've seen the basic migration process. We run it, we identify what we need, we configure the migration, we execute the migration, and we rebuild it. These three parts, the middle parts, identifying, configuration, and execution, are the steps that we can do with Modern or with Open Rewrite, and let us skip step through it. We can identify it in the Modern platform with the marketplace, configure it with the widget, and run it and see the differences. That's the easy part. The step-by-step for the pure Open Rewrite version is we can identify it with the receipt catalog. We configure it usually with YAML, and then we execute it with the Maven plugin run, or with Gradle or the Modern CLI, but that's the part where you may need a license for. Let's come back to write your own, because not everything is there yet. We have to write our own. Just start with the Modern Starter. The Modern Starter is an Open Rewrite recipe starter kit, which brings everything you need. It has an Maven or Gradle build, it has a CI/CD build, it has an pull request auto best practice applier in it, and it has examples for your recipes. With this you can build your own archive and deploy it, and then use it again on the next service you are migrating. One recipe we already seen, the declarative YAML one. We see here a technical one. that's a more technical one. That's a refaster recipe. That's the second easiest way to define a recipe. It is a refaster template. There's another talk from Rick about refaster, which is more detail. But the main idea is that the part within the before template method is replaced with the after template content. So it's very easy to migrate deprecated methods or migrate method usage with a flip in the parameters with that. What we see is the receipt description on the top, which provides the information for the auto-generated documentation. This recipe just replaces the usage of an old method with a better method, maybe a deprecation or so. The last one and most complex one is the imperative Java recipe, and we will not dive into that because it's a very deep topic. We just have a glimpse at it, and at this point we also see how OpenRewrite internally works. OpenRewrite parses the Java class A with a method test and a few instructions, not only as abstract syntax tree, but with abstract as looseless semantic tree, abstract syntax tree with additional information, so the semantics are preserved. And you see that on the lower part, that's the text representation of this parsed tree, and there's a lot more information than in an abstract syntax tree, and this information can be used in a recipe to modify the source code. For every node of this tree, there's a visitor method, and the main idea is you get let's say the method declaration inside. You can decide if you want to change something on that method invocation and return the new migrated method declaration. Very easy on that. But it's very and looks very easy, but it's in principle it is. But you see the massive amount of information just derived from 6 lines of code, and it's not even everything. So it's sometimes it's counterintuitive, but the OpenRewrite community is helping wherever possible. So, what can we do now? Or what should you do now? You should start playing and calculating the numbers. Maybe with a modern platform, just to get an easier start. If you have an open source project, that's everything you need. Just go to Tim and add it, or play around with Spring Boot, Micronaut, basic packages, JavaPro, or any other big open source project or small open source project. And always keep in mind that even the replacement of a simple annotation is very time consuming and very expensive in terms of money. What you also should read is the OpenRewrite documentation. Not the recipe documentation, which is quite nice as well and good to read, but the deeper concepts of the documentation, like what is happening behind the curtains, why it is happening, and what can we do with it. Or the modern YouTube channel is quite interesting from time to time. Not every topic is something for everybody, but it has everything. And collaborate with us. As I said, I'm a member of the OpenRewrite community. Tim as maintainer is here. Rick, I think, also is active there. Just join the Slack, join the Discord, keep in contact with us, or approach us at the conference. I have cookies for you if you try to get one. Just speak with me, grab a coffee, and then we can have a chat about Open Rewrite, migrating your tools, and migrating your software. Okay, I'm a bit in front of the time, but that's not a big problem, because now you have the time to post your questions here, or head out and get a second, third, or fifth coffee of the day without a queue. Thanks for your... Look at slide 1, no questions. Okay, so see you at the coffee table. 2? Huh? Oh, now they're bumped up. Sorry. If you upgrades, for instance, Springboard 3, you only see a target version. Does it matter from which version you start from? Yes and no. It doesn't matter where you start from if you're starting from something newer from 2.0.
Sorry, what was the question?
If you upgrade, for instance, Spring Boot, you only see the target version. Doesn't matter from which version you start. Yes and no. If you start from 2.0, it's no matter. You just say, I want to end at 3.2 or 3.0, and it's migrating the other stuff. That's true for frameworks, where they follow this. It's not always true for every migration, but you can have a look at the migrate Spring Boot recipe list. There's always a definition for this composition, and then you see, okay, if I upgrade to 3.2, I upgrade to 3.1, and I upgrade to 3.0, and I upgrade to 2.7. It runs these recipes, but if you are on 2.7, probably no changes will be there. Probably. Yes. Okay, I checked later. I only saw 2.0. Is Open Rewrite working on an effective POM, or is parting the POM itself? Open Rewrite uses the POM to derive information about the class path, and therefore it's just pathing the POM. But it is also pathing the build version. So when you're applying the Maven plugin, the first step is always a build. So everything which is tied in your build steps will be visible to Open Rewrite as well. Is there a recipe for de-lombocking? Yes, it's called exactly this. Lombok, something without lombok. I think this one. No. Let's see. It should be Java and modernize. Yes. There's lombok. This is lombok, and there's somewhere there's a de-lombok. Down there, I think. To be honest, I don't see it here, but there are de-lombok steps. They might not be perfect, especially with experimental features. But if there is something missing, feel free, open a pull request, and start developing. It's a test-driven approach, so you just copy your snippet, which is not working, in your test, manipulating it by hand, and press test until it's green. So, besides that, you can ask Tim in the third row. We have no further questions. Then, see you again at the coffee table again.